The title for my project is Bank Loan Prediction. This project applies machine learning to classify bank loan applications, aiming to streamline and support the decision-making process traditionally performed by the loan officers. And evaluating the loan application, it's really tedious. It needs time and effort and must confirm the applicants with the historical cases and other factors. And this could also have a risk if the loan is approved or rejected. So they have to make sure that the borrowers are capable to pay for the loan that they will approve. So that's it. We use machine learning to classify for the prediction of back loan applications. Next is the dataset. I got the dataset from Kaggle. Kaggle. So this dataset is for uh, for loan approval classification dataset. It was updated a year ago, so it's quite brand new, and it has 14 variables and 45,000 records. Next is the move on. First, we get the data. Then after we get the data, we unzip. And this is what the CSV file look like. It has uh, the loan status for the target label, the person age, education, person home. We will explore more of the data or visualize more of the data for data exploration. Next, we use pandas to read the CSV. So this is the same what we saw in the Excel. We would see some are numeric, some are categorical. Next is we perform data cleaning. We need to check if the data has missing data. So I use isNull and check every columns, and it says no missing values found. Next is for our categorical. Since we're working with machine learning, we need to convert our categorical data to numerical data. I use ordinal features to convert them. So using a column transformer, I'll be able to convert all columns for the ordinal encoder and just passing all the categorical all ordinal categories, and this will be the output. So we would see that the column names change based on the transformation, and it has the just read. I'm gonna read this. So it has been changed based in the order of the transform column first, then the remainder columns. You see the prefix added and the remainder columns. So in this code block, I will revert back the columns to its old names. So it's going to be the original column names and set them. So yeah, it's going to be the old column names, and it has the numerical data. Next is the data exploration. So as mentioned, we have 45,000 samples available for machine model training. We have 9 numeric columns and 5 non-numeric columns. And then we describe the data. So we'll not be using uh, then the non-numeric, but only the numeric columns to see how many data, the mean, how what is the median. You would see, for example, the person age. We have the max person age, and the median is 26. So it has a skew, skewed distribution. It's because you would see that the mean 27 is very far from 144. Loan status. Also, we would check the income, person income. So this one is very high, I think 7 million, and the lowest is in, I think, 80,000, 8,000. And to better see the correlation between the columns, okay, like that. So one means it's strongly correlated as the as the value is as our target label is one, then the value will follow. This one is like negatively correlated. So the strongest correlation is our previous loan defaults on file, followed by our person home ownership, also the loan interest rate and loan person income. While the lowest correlations is the person gender. So I think the bank officers doesn't really take account the gender when approving bank loans. And also age doesn't also matter, and the employment experience. Also special mention to our credit history length and credit score. So I put the observations right here. So some of the columns are strong, some of the columns are weak. And we will visualize how far. And the data shows that there are more rejected than the approved. So this is the person gender, person education, person from ownership. So we have an unbalanced data, I would say, and previous load defaults on file. That's when when only 10K was approved and the rest is not approved. For example, if you have a default, then you won't, yeah, loan loan defaults on file. Data embed very obvious. Next is we see the numeric columns. There is like a high range that will affect the distribution of our data. I would see that there's an age 140 and the minimum is 20. Person income, this is the one we found earlier that there's a 7 million income that was very sensitive to our mean employment experience. Also is good. Loan amount, loan interest rate, loan person income. I think this one is like quite okay. You can easily visualize that there's a little skewedness compared to our age. This one is the credit history length and credit score, which is from the earlier, it's good from the right and it's good to the left. So for this classification, I have used logistic regression because we're using supervised learning and we're using binary classification or logistic regression. This part is I'm removing the loan status to prepare for the X features and Y features for the Y. You only keep the loan status. This one I will show earlier. Yeah, I will show this one earlier. But first, we're gonna stick with the original one, which is the X and Y axis, X and Y variables. And I built the model using a pipeline since I'll be introducing a standard scaler to to scale the values since sums are large. I use the penalty L2 for the regularization and the solver is the optimization. Yeah, I'll also show later the performance. Let me run this. So we would see that there are more rejected, which is 35,000, and the 10,000 is approved. Next is we will ignore this part. Then this is the sample X and Y. Next is train the model, regression, and evaluate the prediction and collect the prediction based on the new with the new test data set. And we will use the confusion matrix to show and feed that confusion matrix. So we would analyze first what the confusion matrix give us. For the actual, we have 6,557, which is correctly classified as rejected. And this one is approved, which has we have 1,466 samples that is classified as approved. So this one is false. This is false positive. This is false negative because we're in the actual zero. Wait, false positive. They were they were actually they were actually rejected but classified as positive. And so that's why it's false positive. Then we go to here, false negative. They were classified as rejected, but they are actually positive. So 544 samples were classified as negative, but actually positive. Yep, this is the classification and this one. So I have run different cases. First is without using a random oversum clearance mode and using the optimization FGS. It gave me 89% accuracy, 77% precision, and 72.75 for recall, and 74.88 for the F1 score. So this one, comparing to another case, which I use a linear because based on this one can be used for multinomial multiclass, and the other one is for only for binary. The difference is the performance of our linear is better compared for this one. Now I want to introduce another technique, which is the random urban subterranean mode. So this is the choosing the model, which, for example, I give this here. So we would see that there is now balance between the rejected and approved. Then we train the model, we make the prediction, and yeah. What did I use? I use a random oversampler. So it says here the accuracy is 87%. Yeah, because I was using the combination of linear and LFFGS for the random oversense mode. So for the data I collected for this one, scenario C and scenario D, I was using the LFFGS and I changed to linear for exploration or testing out. It changes from so this is originally I'm using random oversampler. Random oversampler is for our case D, 87.41%. Now it's 87.72, which is better because it's scenario D. I was using LFFGS. Yeah, I think this one is also LBFGS. Yeah, so the F1 score was able to get higher, but the performance of our accuracy was lower. So which is because we're dealing with unbalanced data, so that's why I would emphasize of the using of F1 as a evaluation matrix rather than the accuracy, because it definitely we were able to predict more of the rejected rather than the of the approved because of the big difference between the uh labels, small difference between the labels, where the approved is smaller than the rejected. And I think that's it for my project. Thank you.